Okay guys, let's talk this time about solution stoichiometry. This is where all the knowledge you have accumulated so far this semester converges. Stoichiometry, equation balancing, molar mass, molarity, acid and bases, dimensional analysis, limiting reaction, etc, etc, etc. When you are working with solution stoichiometry problems, use the dimensional analysis techniques. First, identify what you know, identify what you need to find, and identify the final question or goal of the problem. Let's look at a couple of solution stoichiometry problems. 1.2 liters of a 3.3 molarity nitric acid solution is neutralized with 5.8 liters of an unknown concentration of barium hydroxide. Solve for the concentration of barium hydroxide solution. So as I mentioned before, let's start with those things that we know from the problem. We have 1.2 liters of a 3.3 molarity nitric acid solution, and we have 5.8 liters of barium hydroxide. What do we need to find out to solve a problem such as this? We know that when we're working with stoichiometry, we must have a balanced equation. So let's start with that part. Now, what is the final question of the problem? Well, we must find the concentration of barium hydroxide on the solution. So let's start with the balanced equation.
As you can see, 2 moles of nitric acid and 1 mole of barium hydroxide reacts together to form 1 mole of barium nitrate and 2 moles of water.
Now that we have all of the information and the balanced equation, we can apply all of the elements to our stoichiometry. 1.2 liters of nitric acid, which is 3.3 moles per liter in concentration. We add our stoichiometry of 2 moles of barium hydroxide to 4 moles of nitric acid. That will give us 1.98 moles of barium hydroxide that the 1.2 liters 3.3 molarity nitric acid will neutralize. Now divide the number of moles of barium hydroxide by the volume of barium hydroxide to obtain the concentration, which is 0.34 molarity of barium hydroxide. Okay, let's go on to the next problem. How many grams of lead-2 phosphate form if 54 milliliters of 0.84 molarity lithium phosphate react with 53 milliliters of 0.16 molarity lead-2 chloride? Be aware that lithium chloride is also a product in this reaction. Once again, identify those things that you know. And next, balance your equation. In this case, we have that 6 moles of lithium phosphate and 4 moles of lead-2 chloride will form 6 moles of lithium chloride and 1 mole of lead-2 phosphate. This is also a limiting reactant problem. Let's take one of them at a time. We have 54 milliliters of lithium phosphate. We know we have a conversion of 1000 milliliters to liters. We also know that we have the molarity of lithium phosphate, which is 0.84 moles to 1 liter.
And we have the mole-to-mole ratio, which is 2 moles of lithium phosphate to 1 mole of lead-2 phosphate,
resulting in 0.00756 moles of lead-2 phosphate. Now let's take a look at lead-2 chloride. We have 53 milliliters of lead-2 chloride. Now we have to add once again the 1000 milliliters to 1 liter conversion, and we have to use the molarity, which is 0.16 moles over 1 liter of lead-2 chloride. And once again, we have to do the mole-to-mole ratio, which is 1 mole of lead-2 phosphate for every 3 moles of lead-2 chloride, resulting on 0.002827 moles of lead-2 phosphate. As you may have noticed, lead-2 chloride is our limited reactant, producing only 0.002827 moles of lead-2 phosphate. Now we can use the molar mass of lead-2 phosphate, which is 779.54 grams lead-2 phosphate over 1 mole of lead-2 phosphate to obtain 2.2 grams of lead-2 phosphate. Okay guys, I hope this was helpful. Please let me know if you have any questions.